Bismillahirrahmanirrahim and Assalamu alaikum. Today we will discuss ionization energy or ionization potential. First of all, what is ionization of atom? This is the complete removal of an electron from an atom. We know that atom is a neutral particle. The number of electrons are equal to the number of protons. And we also know that the electrons are under the attractive force of nucleus. In other words, we can say that the electrons in an atom are strongly held by the nucleus so that they cannot escape from the atom. The electrons which are near to the nucleus experience more attractive force. The electrons which are away from the nucleus will experience less attractive force. It means that those electrons which are away from the nucleus are loosely bonded, or the attractive force of the nucleus on the valence electron is comparatively weak as compared to the electrons which are near to the nucleus. So when energy is supplied to remove the electron from the atom and form a cation, that energy is said to be the ionization energy. We know that nucleus hold the electron and force in the form of energy is needed on the electron to remove it from the gaseous atom. Now let we define the ionization energy. This is the minimum amount of energy required to remove an electron from the valence shell of an isolated gaseous atom. As energy is needed, so we have to measure the ionization energy in the unit of energy. The ionization energy is measured in joules per mole or kilojoules per mole. It is the amount of energy in joules which is required to ionize 1 mole of an atom. Now let we discuss the first and second ionization energy. What is first ionization energy? This is the energy required to remove the first electron from the valence shell of a gaseous atom. For example, sodium lose an electron to form sodium ion. So 496 kilojoules per mole energy is needed. Or in other words, we can say this is the amount of energy required to remove 1 mole of electron from 1 mole of gaseous sodium to form 1 mole of sodium ion. Similarly, the first ionization energy of magnesium is 738 kilojoules per mole. It means that 738 kilojoule energy is needed to remove 1 mole of electron, Avogadro's number of electron, from 1 mole of magnesium, that is Avogadro's number of magnesium, to form Avogadro's number of magnesium ion. If we compare the ionization energy of both sodium and magnesium, we see that ionization energy of magnesium is almost twice to that of the ionization energy of sodium. It means that the hold of the nucleus on valence electron of magnesium is much greater than the hold of the nucleus on the valence electron of sodium. It can also be expressed as ionization energy is the index to find out how much strongly the electrons are held together by the nucleus of an atom. We can say that the electron of magnesium, the valence electron of magnesium, are strongly held by the nucleus of magnesium as compared to that of sodium. The second ionization energy. The magnesium ion lose another electron and form Mg+2. It needs 1450 kilojoules per mole energy. So this is the amount of energy required to remove another electron from a gaseous cation. If we look at the ionization in the second ionization energy of magnesium, it is almost twice to the first ionization energy of magnesium. It is because we know that to remove the first electron, then we have to remove the valence electron from the attractive force of 12 proton. When magnesium lose an electron and form magnesium ion, then the remaining electron are 11. Now 12 proton attract the 11 electron more towards itself, and hence the attractive force of the nucleus on the remaining electron increases. Therefore we have to provide more force in the form of energy to remove another electron. Secondly, we can also say that ionization energy is also an index that how much an electron can be removed from an atom. For example, sodium can lose only one electron, but magnesium can lose two electrons. Why not magnesium lose the third electron? So if the gap between first and second ionization energy is comparable, then it means that the atom can lose another electron. But if the gap between first and second ionization energy is very greater, then it means that the atom cannot lose another electron. For example, if we want to remove the third electron from magnesium, then 7500 energy is needed, which is almost 7 times greater than that of the second ionization energy. It means that sodium cannot lose the third electron. Now, there are some factors which affect the ionization energy. The first factor is atomic radii, nuclear charge, the shielding effect, and electronic configuration. Let me explain it briefly that atomic radius is inversely proportional to ionization energy. If atomic radius is smaller, then ionization energy will greater. Similarly, the ionization energy is directly proportional to nuclear charge. By keeping shielding effect constant, it will be discussed later on, that if the nuclear charge goes on increasing, then ionization energy will also increases. Similarly, ionization energy and shielding effect, they have inverse relationship. Greater the shielding effect, lesser will be the ionization energy. And the third factor, remember that completely filled and half filled orbital are stable and have high ionization energy. For example, let the valence electron of an atom is in p shell, and let p containing 3 electron or 6 electron, then it will have more ionization energy as compared to those atoms in which p subshell containing less than 6 or less than 3 electrons. Now, what are the trends in ionization energy? It means that what happens to ionization energy in periodic table when we move from left to right in a period or from top to bottom in a group. Generally speaking, ionization energy in groups decrease from top to bottom. It means that in a particular group, as we move from top to bottom, the ionization energy will decrease. Similarly, in period, the ionization energy increase from left to right. In a particular period, if we move from left to right, then it means the ionization energy will increases. The reason why in groups ionization energy decreases, we know that as we move from top to bottom in periodic table in a particular group, the number of electron gradually increase, the number of electronic shells gradually increases. Now, first of all, we discuss the ionization energy in groups. As we mentioned earlier, that ionization energy decreases as we move from top to bottom in a particular group. We are discussing the first A. So lithium has 2 electronic shell. The valence electron of lithium is in the second shell. The valence electron of sodium is in the third shell. And the valence electron of potassium is in the fourth shell. As we move from top to bottom, electronic shell gradually increases. Then there are 2 factors are responsible for it. Number 1, atomic radius increases, which decrease ionization energy. Secondly, the shielding effect, the electrons between the nucleus and the valence shell goes on increasing, which reduce the attractive force of nucleus on valence electron. Therefore, this electron is much loosely bonded as compared to the valence electron of lithium. Therefore, it required less energy to remove the valence electron of potassium as compared to sodium and lithium. So, generally speaking, when we move from top to bottom, atomic radius increases, the shielding effect also increases, so the ionization energy of element goes on decreasing. Another very interesting factor, we know that the atomic number increase as we move from top to bottom. It means that the nuclear charge increases, but in this case the nuclear charge is overcome by the shielding effect and atomic radius. It means that those element which has a greater number of proton in the nucleus but their size is bigger, as well as the shielding effect is high will have low ionization energy as compared to those which do not have this property. Now, in a particular period, when we move from left to right, ionization energy is gradually increases. It means that in the second period, boron will have more ionization energy than beryllium and lithium. Or we say that the valence electron of boron are much strongly held by the nucleus as compared to beryllium, that of beryllium and lithium. It is again because of certain factor. Number first, we know that as we move from left to right in a period, the number of proton gradually increases. The nuclear attractive force on the valence electron increases. Secondly, we know that with the increase of nuclear charge, as the shielding effect, the shielding electron remain constant. Both all these three elements has only two shielding electron, so the shielding effect remain constant. Now the nuclear attractive force will affect the ionization energy. So from left to right, number one, nuclear charge goes on increasing. Look at this. The atomic number of lithium is 3, it has 3 proton. That of beryllium is 4, it has 4 proton. And boron has 5 proton. So from left to right, the number of proton gradually increases. The number of shell remain constant, and the size of atom also decreases. So smaller the atomic radii and greater the nuclear charge will make the ionization energy to increase. So from left to right, we say that the ionization energy of element goes on increasing. So it is all about the ionization energy, the first and second ionization energy, the trends of ionization energy and periodic table. So that's it. Thank you and have a nice day.